Okay, in this presentation, we're going to discuss about types of work. So as we understood that work is the product of force and displacement in the same direction. Now here, we need to understand the three types of work: positive work, negative work, and zero work. Positive work means whenever the force and displacement are parallel to each other. In other words, force and displacement both are in the same direction, then we can say the work is maximum and positive work is done. When the force and displacement are in opposite direction as shown here, then we can say the work is negative. Generally, negative work done example, if you think, then you can say the amount of work done by the frictional force is negative work. Now coming to zero work done. Zero work done happens. Zero work done means work is zero. There is no work is done. And it is possible when force is perpendicular to displacement. Why in this case work is zero, I am going to explain you in a few moments. So let me start with the positive work example. Now see here. In this example, if you see carefully, there is a trolley which has some engine inside, and that engine is pulling the trolley in the forward direction with the force F equal to 150 newtons. There is a frictional force between the tires of the trolley and the road, and the trolley has moved a distance of 100 meters towards right side. And the question is, what is the amount of work done by the engine force 150 Newton? What is the amount of work done by friction? So first of all, we solve the first question. So as we know that the amount of work done, W equals to F into S. Yeah, you may get doubt that why I have not written cos theta. As I mentioned in the first part of this presentation, that when theta is 0 degrees, then cos 0 is 1, and here theta is 0 degrees because force and displacement both are the same direction. Then displacement, then angle between them is 0, and it is maximum work done, and W equal to Fs. So that's why I have taken this formula. Now W equal to Fs equals to, what is the force? 150 into displacement is 100 meters. So the answer is 15,000 joules, and it is positive work. It is positive. Now next question, if you see, what is the amount of work done by friction? Friction direction and displacement direction, if you see, both are in opposite direction. As both in opposite direction, the work done by friction is negative work. So hence W equals to F into S. F into S equals to F is 2 Newton into the displacement is 100, which equals to 200 joules, and which is a negative work. So it is negative. Okay, now if you ask a question that what is the net work done, so how can you solve this? Yeah, it's very simple. Net work done is nothing but you need to see the amount of positive work minus amount of negative work. So positive work is 15,000 minus negative work is 200. So the amount of net work done is 15,000. So 15,000 minus 200, which is 14,800 joules. This is net amount of work done, and here no need to tell the direction because work done is a scalar quantity. Now see this example. There is a person, say coolie, who is kept a suitcase or a box on his head and walking in the forward direction, horizontally. Now the question is, what is the amount of work done in the direction of motion? Now if you see here, as the displacement horizontally, like shown here, and when he put the luggage at the suitcase or the box on his head, this luggage has weight acting downwards. So therefore we can say this is the weight acting downwards. W is the weight, and weight is also a force. So let me write this is as force. Don't confuse with the symbol. Here work done, weight have the same symbols, that's why I changed the weight to F. So the weight F acting downwards and displacement is horizontal. And if you see the angle between them, and you get understand the angle between them is 90 degrees, because both are perpendicular. And when it is 90 degrees, we know the formula of amount of work done. W equals to F into S cos theta, and theta is 90 degrees here, and cos 90 according to trigonometry it is 0. Therefore F into S into 0, which is equals to 0 joules. So hence the amount of work done is 0. Now here see two more cases. There is a force exactly acting perpendicular to the wall, but the wall still is not moving. When the wall is not moving, its displacement is 0. When displacement is 0, if you write S equal to 0, which is displacement equals 0, according to formula W equals to F into S, which is 0, equal to 0. That means amount of work done is 0 when displacement is 0 in this case. Now see the one more case here. So here say friction equals to 20 Newton. Now there is a trolley moving in the right side direction with the applied force 20 Newton. Simultaneously there is a friction force between the tires of the trolley and the road is 20 Newton. Then the net force equals to capital F minus small f, and capital F minus small f is how much? 20 minus 20, which is equal to 0. So here the net force is 0, and if you write the formula again, W equals to F into S, which is 0 into S equal to 0. That means here also work done is 0. So what I wanted to tell you that amount of work done is 0 in three ways. One is when the force is perpendicular to displacement, as we discussed earlier slide, and work done is 0 when displacement is 0. Work done is 0 when force is 0 also. Now here I wanted to give more emphasis on this example. You may have doubt that when the force is 0, how can we say work is done? How can we say the body is moving? Because I'm saying displacement is there. So trolley is moving even the force is 0. Yes, it is correct, because when the net force is 0, you can say that when the net force is 0, then its acceleration A equal to 0. When acceleration A equal to 0, then we can say the body moves with constant velocity. Just recall the kinematic equations and Newton's second law. Newton's second law is F equal to ma. Let me write here F equal to ma. So what happens when A equal to 0 here, then F equals to 0, and here this F is the net F. Let me write here F net. Yeah. So when F equal to ma, the net force is 0 because acceleration A equal to 0. And the acceleration A equal to 0, according to kinematic equations, we know that the acceleration change in velocity. So it means change in velocity V minus U equal to 0, therefore V equal to U. Therefore V equal to constant. So the body moves with constant velocity. In that case, the amount of work done is 0. Yeah. Now we going to discuss about energy concept. As you know that if you want to do any type of work, what we have discussed earlier, you should have energy. Without energy, you can't do work. At the same time, how much of energy you have, that much of work only you can do. You cannot do the work which is more than your energy. So, and hence, energy is the capacity of doing work. It is the capacity of doing work. As I said, energy is the capacity of doing work. Work and energy both are interchangeable. Wherever you say work, you can say energy also. And so, work SI unit is also the SI unit of energy. And hence, the SI unit of energy is joule. So, in the previous examples, if you see the amount of work done, you have mentioned here 0 joules, 0 joules. You can say that the amount of energy is also 0. Right. So, let us go in details of the energy. We have many types of energies, like we have electrical energy, mechanical energy, and nuclear energy, electromagnetic energy, solar energy, geothermal energy. So many energies are there. But here a point of discussion is mechanical energy. This mechanical energy again classified into two types: kinetic energy and potential energy. So kinetic energy is the energy generated when the body is in motion. That means you suppose think that you are driving a car is moving in the forward direction. That means car has kinetic energy. You are running on the road. That means you have kinetic energy. You have thrown a stone and the stone is rolling on the road. It has kinetic energy. So whatever the object, if the object is in motion, it has kinetic energy. See the example here. If there is a block of mass m moves with velocity v, then the kinetic energy formula is given by Ke equal to half m v square. Remember it very carefully. Ke is a short form of kinetic energy, which is equal to half into m into v square. That means kinetic energy depends upon mass and velocity square. How it is? Let me explain you. So kinetic energy is directly proportional to mass. Kinetic energy is directly proportional to v square. Directly proportional means how much the right hand side variable increases, that much the left hand side variable also increases. If mass is doubled, kinetic energy also doubled. If mass is reduced to half, kinetic energy also reduced to half. Similarly, if velocity is doubled, listen to me carefully, when velocity is doubled, then kinetic energy becomes 4 times, because v square doubled means 2 square, 2 square is 4. If velocity is tripled, the kinetic energy is 9 times increased. So that's how it is directly proportional ratio between mass and velocity square. Now see this example. A 2 kg mass travels with 0.4 meters per second. That's kinetic energy is. So let us write the kinetic energy formula: half m v square. Okay. Now 1 by 2 into what is mass? 2 into velocity is 0.4 square. So when you write 0.4 square, see this carefully. Now if you simplify this, 2 will be cancelled. 0.4 square is nothing but equals to 0.16 joules. Okay. Now see the below one more example. The same mass 2 kg, now it travels with velocity 0.8 meters per second. Means velocity is doubled. 0.4 into 2 is 0.8. Then what is kinetic energy? Earlier I have mentioned you, when the velocity is doubled, kinetic energy is not doubled, kinetic energy is increased to 4 times. So let us see. So Ke equals to 1 by 2 into mass is 2 into what is velocity? 0.8 m square. Now as usual, you can see that the 2 can be cancelled. The 2 can be cancelled. 0.8 square, which is 0.64 joules. So earlier it is 0.6 joules, and this is how much? 0.16 joules. So if you see the earlier the kinetic energy is 0.16 joule. Now the kinetic energy 0.64 joule. So how many times kinetic energy increased? So the kinetic energy increased to, if you see here, the kinetic energy increased to 4 times. 16 into 4 is 64. So as the velocity is doubled, kinetic energy increased to 4 times. So that's how they have directly proportional relationship. Potential energy, the second part of mechanical energy. Potential is the energy it is the energy due to work against gravity. Gravity means gravitational force. If any body is moving against the gravity, then we can say the body has potential energy. And one more definition is also there. Potential energy is the energy stored inside the body. So potential energy is due to change in the size and location, size and shape of the body also. That's why sometimes this potential energy, which is the work against the gravity, is also called gravitational potential energy, GPE. Sometimes we call that GPE. So I can write this as a GP. So it's called GPE, gravitational potential energy. Now you see the formula potential energy, which is mass into acceleration due to gravity into h. H is the height. So that is this is what the formula of potential energy. So let us discuss more about potential energy by solving some numericals based on this. As I mentioned earlier, potential energy is the energy generated due to change in shape or size also. See the example, this small spring. When the spring is stretched with the force outwards, and what happens as you release the force, the spring comes back to the same position, same state, because internally some forces are developed, and those forces develop the potential energy inside. So when you change the shape, the body generates potential energy. See this example, there is a ball. This ball is applied by two forces. That means the ball is pressed in the two sides so that the ball becomes in this shape. When you release the force, the ball comes back to the initial position. This is because as soon as the force is applied, the ball generates potential energy. That's why it is the energy stored inside the body also. See this a small example. There is a ball of mass 350 grams which is lifted up or thrown up to a height 2.5 meters. Now you need to calculate the potential energy of the ball. So as you know, the formula PE equals to M into Z into H. So mass is 350 grams. Please convert it into SI system, which is 0.35 into G value. Acceleration due to gravity is always 10 meters per second square. 10 into height is 2.5. Now if you simplify this, you get the answer 8.75 joules. So this is the amount of potential energy gained by the body when you go to a height of 2.5 meters. Now see this example. Here there are steps 1, 2, 3. The 3 steps are there, and a body of mass 30 kg climbed the steps to the height of 5 meters in one case. In the other case, the body has directly moved to a height of 5 meters with the help of a rope. Now the question is, which case the potential energy is more? So let us find. In the first case, PE1 equals to mgh. You know the formula, m into g into h equals to what is mass 30 kg into g, always 10, into height 5. So the answer is 5 3 is 1500 joules. Now PE2, same formula if you apply, you will get 1500 joules. How it is possible? In both the cases you have the same potential energies. Yeah, because potential energy doesn't depend upon the path the body has traveled. It depends upon the height and mass and acceleration due to gravity. Even the body has traveled in the first case in different directions in the different steps, still we consider the height only, which is 5 meters. So that's why we have written 5 meters height, as the mass is same 30 kg and g is acceleration due to gravity 10, which is 1500 joules. In the second case also mgh you get 1500 joules. So we can write PE1 equal to PE2. Hence it proves that it doesn't depends upon the path. Does not depend on the path.